Welcome back, dear students, to the Standard 7th subject Mathematics, Chapter 13 Pythagoras Theorem, Module 2. Let's recall what we have studied in our previous session. We know that a triangle with a right angle is called a right angle triangle, and the side opposite to the right angle is called the hypotenuse. Then we have seen Pythagoras theorem. So Pythagoras theorem states that in a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Hypotenuse square, that is equal to height square plus base square. This is the formula for Pythagoras theorem, or we can say that c square, that is equal to a square plus b square. In today's module, we will discuss practice set 48. Question number 1 is, in the figure below, find the value of x. So here three different figures are given and we have to find out the value of x. So let's see the solution. First one is, in triangle LMN, angle M is equal to 90 degree. So here you can see angle M is 90 degree. Hence side LN is the hypotenuse. So LN is hypotenuse. According to the Pythagoras theorem, length of LN square, that is equal to length of LM square plus length of MN square. X square, that is equal to 7 square plus 24 square. So students, we already know the square of 7, that is 49, and square of 24, that is 576. Therefore x square, that is equal to 49 plus 576. Now we will add this. So x square, that is equal to 625. So here in this diagram you can see we have to find out the value of x, and here we have x square. Now we will take square root of 625. So x is equal to square root of 625. Now students, we will further factorize 625. So x is equal to square root of 25 multiplied by 25. Now we can write like this also, square root of 25 square. Now we can easily cancel square and square root. So x is equal to 25 units. Question number 2. In a triangle PQR, angle Q is 90 degree. Hence side PR is the hypotenuse. According to the Pythagoras theorem, length of PR square, that is equal to length of PQ square plus length of QR square. So here length of PR square, that is equal to length of PQ square plus length of QR square. So here PR is 41 and QR we have to find out. So that is x, and PQ, that is 9. Therefore 41 square, that is equal to 9 square plus x square. So we will find out the square of 41, that is 1681, that is equal to 9 square is 81, 81 plus x square. So 1681, that is equal to 81 plus x square. Now 81 we will take on the left hand side, it will become negative. So 1681 minus 81, that is equal to x square. So x square, that is equal to 1600. So students, here we have to find out the value of x, and here we have x square. Now we will take square root of 1600. So x is equal to square root of 1600. Now we will further factorize square root of 1600. So we will get x is equal to square root of 40 multiplied by 40, that is equal to square root of 40 square. Now we can easily cancel square and square root. Therefore x is equal to 40 units. Question number 3 is, in triangle EDF, angle D is equal to 90 degree. Hence, side EF is the hypotenuse. According to the Pythagoras theorem, length of EF square, that is equal to length of ED square plus length of DF square. So here we have to find out ED, means here value of x. Here length of EF square, that is equal to length of ED square plus length of DF square. So here EF, that is 17, and DF, that is 8, and ED means x centimeter we have to find out. So 17 square, that is equal to x square plus 8 square. So 17 square, that is 289, that is equal to x square plus 8 square, that is 64. So 289, that is equal to x square plus 64. Now 64 we will take on the left hand side and it will become negative. So 289 minus 64, that is equal to x square. So here x square is equal to 225. Students, here we have to find out the x, and here we have x square. So we will take square root. So square root of 225. So here we will further factorize this. So x is equal to square root of 15 multiplied by 15. So here we can write like this also, square root of 15 square. So we can easily cancel square and square root. So x is equal to 15. So x is equal to 15 units. Question number 2. In the right angle triangle PQR, length of P is equal to 90 degree if length of PQ is equal to 24 centimeter and length of PR, that is equal to 10 centimeter. Find the length of segment QR. So here we have to find the length of the segment QR. Let's see solution. So in this diagram you can see triangle PQR where angle P is equal to 90 degree. So hence side QR is the hypotenuse. So here you can see side QR is the hypotenuse according to the Pythagoras theorem. Here length of QR square that is equal to length of PR square plus length of PQ square. So here in this diagram you can see PR that is 10 centimeter and PQ that is 24 centimeter and QR we have to find out. So length of QR square that is equal to 10 square plus 24 square. So 10 square is 100 and 24 square is 576. Therefore, length of QR square that is equal to 100 plus 576. So when we add, we will get length of QR square that is equal to 676. So now here we have to find out the length of QR, and here we have length of QR square that is equal to 676. So students, here we will take square root of 676. So length of QR that is equal to square root of 676. Now this we will further factorize. So we will get square root of 26 multiplied by 26. Now this we can write like this also. Length of QR that is equal to square root of 26 square. So now we can easily cancel square and square root. Therefore, length of QR that is equal to 26. So the length of segment QR is 26 centimeter. Question number 3. In the right angle triangle LMN, angle M is equal to 90 degree if length of LM that is equal to 12 centimeter and length of LN that is equal to 20 centimeter. Find the length of segment MN. So here we have to find the length of segment MN. So in this picture you can see in triangle LMN, angle M is 90 degree. Hence side LN is the hypotenuse. So according to the Pythagoras theorem, length of Ln square that is equal to length of Lm square plus length of Mn square. So Ln that is 20 centimeter and Lm that is 12 centimeter. Therefore 20 square that is equal to 12 square plus length of Mn square. So now we will take 12 on the other side, it will become minus. So length of Mn square that is equal to 20 square minus 12 square. So here length of Mn square that is equal to 20 square that is 400 minus 12 square that is 144. So 400 and minus 144. So here we will get length of Mn square that is equal to 256. So when we subtract we will get 256. Students, here in this diagram you can see we have to find out Mn, and here we have length of Mn square. So here we will take square root. So length of Mn that is equal to square root of 256. So students, now we will further factorize square root of 256. So length of Mn that is equal to square root of 16 multiplied by 16 that is equal to square root of 16 square. So here we can easily cancel square and square root. So length of Mn that is equal to 16. Therefore, the length of segment Mn is 16 centimeter. Question number 4. The top of a ladder of a length 15 meter reaches a window 9 meter above the ground. What is the distance between the base of the wall and that of the ladder? So here we have to find out the distance between the base of the wall and that of the ladder. So let's see solution. So in this diagram you can see here the wall and the ground are perpendicular to each other. So in this figure you can see wall and the ground are perpendicular to each other. Hence, the ladder leaning against the wall form a right angle triangle. So, in a triangle ABC, angle B is equal to 90 degree according to the Pythagoras theorem. Length of AC square that is equal to length of AB square plus length of BC square. So AC is 15 meter, AB is 9 meter and BC we have to find out. So length of AC square that is equal to length of AB square plus length of BC square. Therefore 15 square that is equal to 9 square plus length of BC square. So 15 square that is 225 that is equal to 9 square is 81 plus length of BC square. So 225 is equal to 81 plus length of BC square. So here length of BC square that is equal to 225 minus 81. So when we subtract we will get length of BC square that is equal to 144. So now students you can see here we have to find out length of BC and here we have length of BC square. So we will take square root of 144. So length of BC that is equal to square root of 144. Now we will further factorize square root of 144. So we will get length of BC that is equal to square root of 12 multiplied by 12. So we can write like this also, length of BC that is equal to square root of 12 square. So we can easily cancel square and square root. Therefore length of BC that is equal to 12. So the distance between the base of the wall and that of the ladder is 12 meter. Students, here we completed with practice set 48. Thank you dear students.